In 11.2, we're going to continue our techniques for evaluating limits. So a lot of this will be the same. There is one new technique we are adding to this lesson, and it's the rationalizing technique, which I will show you in example 3. So let's go ahead and practice some of our methods that we have used from 11.1. Example 1, find the limit as x approaches negative 3 of x squared plus x subtract 6 over x plus 3. If I try direct substitution, that negative 3, if I directly substitute it, negative 3 plus 3 is 0, and that is not going to work. So now I'm going to try step number 2, which is if direct substitution fails, try factoring and canceling, which is called the dividing out technique. So I have the limit as x approaches negative 3 of this function, and I'm going to go ahead and factor that function. So it's multiply to get negative 6 and add to get 1. So it's 3 times 2, and it looks like our 2 is the one that will be negative. So this is x plus 3 and x subtract 2 over x plus 3. And sorry, I'm writing over the original problem, but it's all good. All right, so the x plus 3's are going to cancel. And now I can just go ahead and use substitution. So I will substitute in the limit of x approaching negative 3 in here for x. So this is going to be negative 3 subtract 2. And the answer is negative 5. Therefore, the limit as x approaches negative 3 of this function, which I will refer to as f of x, is equal to negative 5. I want to go over what this limit looks like graphically. So looking at the original problem, do you remember when we did rational functions, if the denominator canceled with the numerator, there ends up being a hole in the graph? So we're going to graph the linear function f of x equals x subtract 2, and we're going to put a hole in that function. So to graph this, it's linear, so we'll start at negative 2, and then it's rise over run. So rise 1, run 1. Maybe I'll use a different color so you can see this a little better. So you're at negative 2, rise 1, run 1, or you could go down 1 to the left 1. And that's when x is negative 1, we're down here at negative 3. Let's from that point go down 1, left 1. And down 1, left 1. Now, when x is negative 3, it's undefined, and that's why there's going to be a hole in that graph right there. So if I were to draw this linear function, it looks like this. And you can see as I am coming into negative 3 from the left side, I'm here, here, here. You can see that I'm approaching negative 5. And when I come into negative 3 from the right-hand side, I'm also approaching f of x equals negative 5. Therefore, my limit is negative 5. In this problem, we're going to find the limit, and the limit as x approaches 1 of this function. Direct substitution is going to give me a 0 on the bottom of the function. So we're going to try our factoring method, which means we're going to split the middle. We've got 4 terms here. In the first group, we can factor out an x squared, which leaves me with x subtract 1. And in the second group, I have an x subtract 1. So you see in those two groups, I have common and x subtract 1. So x subtract 1 will factor out, and I'm left with x squared plus, and there is a 1 placeholder here, so you do have to put plus 1, just so you know. All right, so that's the denominator factor. So let's come back and do the limit. The limit as x approaches 1 of, and on the bottom, we have x subtract 1 times x squared plus 1. And the numerator, we have x subtract 1. And you see how nicely this works out because the x subtract 1s are going to cancel. And then that's going to leave me with this that I can now use direct substitution, plug in 1 for x. So this is going to equal, you've got a 1 on top, and on the bottom you'll plug in 1 squared plus 1. This is going to give you 1/2. So the limit of as x approaches 1 of this function is equal to 1/2. In this example, we're going to use the rationalizing technique in order to find the limit. So if I were to use direct substitution and plug 0 in for x, it gives me 0 in the denominator. So that doesn't work. It also doesn't work for me to factor because nothing will factor here. So here is a new method, and this is to multiply the top and bottom of this fraction by the conjugate. So the conjugate is the square root of x plus 1 plus 1, and the square root of x plus 1 plus 1. Notice this is a minus b, and this would be a, same number, square root of x plus 1 plus b. All right, so when we multiply the top and bottom by the same thing, we're really just multiplying by 1. So let's go ahead and see what we have after we multiply that out. So we have the limit as x approaches 0, and we're going to multiply this out. First times first, and I think I like parentheses around that too. First times first. So the square root of x plus 1 times the square root of x plus 1 is simply x plus 1. Outsides. 1 square root of x plus 1 minus 1 square root of x plus 1 cancels. And last times last, negative 1 times 1 is negative 1. In the denominator, we have x, and we're not going to multiply this. We're going to leave it. So we have x times the square root of x plus 1 plus 1. And the reason why we're going to leave it is because we are hoping things will cancel so we can use direct substitution. So sure enough, we have a plus 1 and a minus 1, which will cancel. And then that leaves us with just x over x. This is multiplication, so we can cancel it. So the x's will cancel, and now there's just a 1 left on top as a placeholder. So now we end up with the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And the plus 1 is outside of the radical. Looks like we can use direct substitution now. Yay! So this will be 1 over the square root of, and we'll plug in 0. So we have 0 plus 1 plus 1. Well, the square root of 1 is 1, and 1 plus 1 is 2. So this is going to give us 1/2. So this is what the limit is. Now what I recommend you do is graph it on your calculator so you can see it graphically, and then also look at your table on your graphing calculator and look at how as you approach x from the left and the right side, f of x is equal to 1/2.